Hello, everybody. So we're going to talk about some of the long-term effects and diseases and whatnot that can come from blood vessels. So we left off last time where we were talking about hypo and hypervolemic situations. We're going to talk about objectives, and by the way, this video is objectives 12 through 18. Objectives 12 is describe circulatory shock and discuss its significance. Shock is what happens when part of you is not getting enough blood for whatever reason, and you have different types of shock because there are different medical ways to treat different types of shock, right? Circulatory shock means the system is unable to maintain blood flow throughout your entire system and supply oxygen and nutrients to everything. Systemic shock means the system is unable to maintain your blood flow. Something has gone wrong and happened that is preventing that, right? That is circulatory shock. Hypovolemic shock is typically caused by hemorrhaging blood. That means you are bleeding out and you have fluid loss, right? Signs and symptoms of this, you're going to develop a slow heart rate or tachycardia. You're going to have a weak pulse because you're bleeding out. Your heart is going to try to beat faster to get blood going around faster. And you're going to have very shallow breathing because everything is flowing out of you. That's hypovolemic shock, right? If somebody is experiencing hypovolemic shock, they're probably going to try and ensure that you don't bleed out and give you a blood transfusion rather quickly. Right? There is cardiogenic shock, which is the inability of the heart to maintain the cardiac output that they need, or that your body needs. Things that will affect this would be valve disorders, arrhythmias, cardiomyopathies, cardiac failure, all the stuff we talked about when we were discussing the heart in your mini heart unit. Right? Vascular shock means your arterioles lose the normal muscular tone or dilate dramatically, right? That means your arterioles are no longer controlling the same level of blood pressure that they used to, and they're just permanently stuck open, for lack of a better term. Sepsis, which is blood infection in your blood, can cause this. Right? So can anaphylactic shock, right? So when you experience that sudden allergic reaction to something super bad because your body has decided that peanuts are evil and are out to get you, anaphylactic shock will cause all of these little arterioles to be open and stay open. That's not necessarily a good thing long term. We know that anaphylactic shock can lead to death. And then you have obstructive shock. That's what if you end up with a blood clot that is so large it just cuts off circulation to a limb of your body because it's in your femoral artery or something like that. Your body is going to experience some degree of shock because of that, right? Here we have the pulmonary circulation or pulmonary circuit. Objective 13 was describe blood's pathway through the pulmonary circuit and discuss the implications of this circuit, right? You guys already know this pathway. You've had it drilled into your heads. I know you know it. Y'all are brilliant, right? The pathway is blood will flow up the pulmonary trunk, through the pulmonary arteries, in through the little arterioles to the different parts of the lung that it needs to go to. It's going to hit the capillaries that are around the parts of your lungs, trade oxygen and carbon dioxide, then flow back through venules, which are small, tiny veins, and then back to the pulmonary veins, then back to the heart. That is your pulmonary circuit, right? You know your pulmonary circuit is from the heart to the lungs, back to the heart again. If there is a blood clot somewhere in that pulmonary circuit, though, you can see all of the lovely little blood vessels that are around in your lungs, right? If there is a blood clot somewhere in there, it has a fancy name, right? It is called a pulmonary embolism, meaning there's a blood clot or embolism somewhere in your pulmonary circuit. That means it can permanently damage that section of your lung, or it can be fatal if the pulmonary embolism is bad enough and it cuts off blood supply in the wrong location. It can damage both your heart and your lungs if you manage to live through the pulmonary embolism, which is why this sort of thing is important to talk about and discuss. This is also extremely bad if the blood clot came from somewhere else in your body and then just suddenly got stuck in your lungs, right? So we've been talking about your systemic circuit and whatnot mostly. Objectives 14, 15, and 16. Talk about this. Objectives 14 was to discuss the functions of your systemic circuit. Objective 15 is name and describe the locations of all of your major arteries and veins in systemic circulation. Objective 16 was to discuss the structure and special function of the hepatic portal system. I know I've mentioned this in lab before, and what we're not talking about anything new that you guys have not heard in lab, right? Systemic circuit is blood flowing from your heart to your body back to your heart again. This is going to feed all of the cells in your body. We talked about that with your heart, right? Some of the major arteries you should know about. The artery that is flowing through past your armpit here is called your axillary artery. The artery that is branching off of this abdominal aorta here, that feeds your intestines, are called your mesentery arteries. You have a top and a bottom one, so a superior and an inferior one. But those are the arteries that are flowing to your intestines. The brachial artery is the large artery down the middle of your upper arm. The common carotid artery are the large arteries right here in your neck. They end up splitting to go internally and externally and form the internal and external carotid artery. And then you have this region of the aorta here called the celiac trunk that is going to branch into your gastric, splenic, and common hepatic arteries. Right? And we know that your common hepatic artery is going to feed your liver. Right? Here we go. We know that your common hepatic artery is going to feed your liver, but your liver gets a little bit more complicated when we start talking about veins, right? The hepatic vein, or common hepatic vein, is used to get blood from your liver back to your heart. So the hepatic veins here are going to dump everything back into the inferior vena cava. So that's the job of hepatic veins. You also, though, have a large vein called the hepatic portal vein. Because your liver's job is to filter blood coming from the intestines to make sure with the nutrients you just absorbed, you didn't also absorb poison, right? Because some poisons are tricky, and your liver is your body's poison control center and filter. All of the veins coming back from your intestines end up merging together to form the hepatic portal vein. And the hepatic portal vein is the large vein that flows into your liver, delivering blood that your liver has to filter. And then once that blood has been filtered, your liver combines that blood from the used blood it used as its own nourishment, and then everything from the blood that came to your liver in the artery or the blood that came to your liver from the hepatic portal vein combine in these hepatic veins going back to the inferior vena cava and back to the heart. But that is the difference between hepatic veins and hepatic portal vein. The hepatic portal vein is carrying blood back to the liver that your liver needs to filter. The hepatic veins are dumping the used and filtered blood back into the inferior vena cava to go back to the heart. Those are the big differences there. And then your final objectives, objectives 17 and 18. Objective 17, describe some changes that occur to blood vessels as a person ages. And 18, describe unique aspects of fetal circulation. So, as you age, we've talked about varicose veins. your valves can, or your veins and the valves in them can give out and start warping a little bit. That can cause blood to backflow and can cause your veins to distend and twist, which is going to cause more blood to pool and adversely affect your blood flow. That's what varicose veins does. Your arteries can get stiffer, which makes your blood pressure go up because your arteries cannot compensate for your heart beating anymore. That kind of stuff is typical as you get older. So important things to know about fetal circulation, right? So the umbilical cord contains the umbilical vein and the umbilical arteries that are going to connect the fetus's blood supply to the mom's placenta for nourishment. So the umbilical cord's job through blood supply that it's traveling through the umbilical cord is sitting there to attach to the placenta of mom and trade waste byproduct for oxygen and whatnot in the placenta, and then take all of this back to the fetus's system. Right? That's how this works. So you get food and oxygen supply from the mother that is fed into the placenta, and then the umbilical cord here, through these umbilical veins and arteries, go from the placenta to the fetus and back again. This is how things are traded between mother and fetus. And that covers all of your objectives for blood vessels. I hope you have a wonderful evening. Have a good night.